Okay, let's talk about histogram. So consider data consisting of observation on a discrete variable x. So again, the frequency of any particular x value is the number of times that value occurs in my whole data set, right? And then the relative frequency of a value is the fraction or the portions of time the value occurs. So for example, we are saying that our data set consists of 200 observations on a discrete variable x, and x is basically the number of courses a college student is taking this term, right? So if 70 of these x values are 3, then this means the frequency of x value is 3, or you can say that uh, this value is 70, means that the value of 3 appeared 70 times in the data set of 200, means the frequency of this value 3 is basically 70. And then when I'm saying that what is the relative frequency of this x value of 3, that would be 70 divided by my total data set. And remember that we said in the beginning that the data set is basically or data set consists of 200 observations, so that is a relative frequency. um, this is another example of relative frequency. So we can see here that the frequency of class A is 478 and relative frequency is 0.191, so almost like 19%. Relative frequency of B is the most, and here you can see that 893. 893 is the frequency for B. For C it is 680, and relative frequency for C is 680 divided by 2501. So this is how we are drawing uh, frequency histograms and relative frequency histograms. Um, Here are the steps which are for students, and it's their assignment to draw frequency histogram and relative frequency histogram. But remember that instructions are for Minitab, so it's a very good idea to download Minitab software and then follow the instructions which I provided on this particular slide to draw frequency histogram and relative frequency histograms. And here you can see that the number of bins, they can always edit number of bins. Histograms are basically graphical representation of the probability distribution of data, and histogram is a very powerful tool, and it's used in quality control. As we mentioned before, that uh, that the number of cells, the number of bars or number of bins are basically square root of number of total observations in the data set. If most of the meat is on the right hand side, then I can say that okay, my histogram is negative skewed or left skewed, or I can also say that okay, it is a left tailed histogram. On the right hand side we have another histogram. We can say that this one is a positive skewed or right skewed or right tailed histogram, right? Because most of the meat or most of the mass is on the left hand side. And this is real data. Here you can see on left hand side we have negative skewed histogram, and on right hand side we have positive skewed or right tailed histogram. Other types of frequency distribution graphs could be bar graph, polygon of data, and CTF. So they are basically providing you the same information, just the depiction method or style is a little different. So it doesn't matter if you want to use a bar graph or polygon graph in your data analysis. It just depends on your needs and the way you are representing data for the viewers or readers to understand. Let's talk about the measure of central tendency. So sometimes we need point estimators which will give you some sensible information about data. What does that mean? Is that I have only one value, and then that one value is giving me information about my whole data. So there we can say okay, three measures are very commonly used: uh, average, median, mode. Mode is the value that occurs with the highest frequency, and it is very possible to have no mode in a series, or very much possible that to have more than one mode. So if there is too much difference in my data values, like let's say if I'm if I want to draw a graph for time it takes to reach from Hayatabad to university, Seacoast University, right? I am taking 100 observations, and the second one would be the data required to reach from Hayatabad to Nowshera, let's say, a case in point. So if I'm drawing that with the help of a histogram, right? So here I will have two peaks. So let's talk about mean. As I mentioned, that mean is a point estimator. So let's say for a given set of numbers, let's say x1, x2, x3, x4 up to xn, and we are interested in finding the sample mean. So the sample mean would be, what I need to do is to add up all those values divided by the sample size. Sample size is a very, it's like the more sample size I have, the better it is. And mean is a very powerful and very useful point estimator. So if one type of battery is giving me a life of, let's say, 12 months, and the second type B is giving me 18 months, the average value. So I will definitely choose type B battery or type A because it's giving me more life. So that's why I said that it is a very useful. However, mean is a very sensitive point estimator. So let's say if I'm adding an outlier to my data set or subtracting an outlier, then it will change the mean value very drastically. So let's say if you have outliers in your data, right? If you want to calculate the mean, so it's a very good idea to calculate mean with outliers and also without outliers. And when you are basically not including outliers in your data analysis, so you can call this as a trimmed mean. So it's also another option for students, right? Let's talk about the median. So the median is basically the middle value, right? The sample median is indeed the middle value once the observations are ordered from smallest to largest. So if my values are odd, then what I need to do is to take the two middle values and then just average whatever the average is, that will be my median. And for odd, so what I need to do, n plus 1, so n 1 2 3 4 5 6 7 plus 1 8, 8 divided by 2, fourth order value. So 1 2 3 4, so here the fourth order value is 6, so 6 is the median here. That's how we calculate median, sample median.